Hi, folks. In the last section of chapter 1, we're going to learn how to solve literal equations. And we've used literal equations throughout this chapter, like for instance, when we've said speed equals distance divided by time. And then I've given you other versions of that equation where distance is speed times time. Being able to rearrange an equation like that on your own is an extremely important skill in algebra. And that's what we're going to learn in this section. We're going to learn how to rearrange literal equations to solve for one variable in terms of other variables. You can rearrange equations just like we've been doing all chapter, even when you've got multiple variables. Like, I don't know what the speed is, I don't know what the distance is, I don't know what the time is, but I can still rearrange those letters using mathematical operations the same way we've been doing with constants. Formulas are a particularly important kind of literal equation. It shows how one variable is related to one or more other variables like distance, speed, and time. So let's look at how we can rearrange equations, literal equations. Solve this literal equation for y. What this means is we want to get y all by itself on one side of the equation. Here, y is not all by itself. It's being multiplied by 3, and then I'm adding on some version of x to it. I want to rearrange this equation so it means the exact same thing. It's an equivalent equation, just with y all by itself on one side. When you are rewriting literal equations, the first step is to simplify if necessary. Now, there's no simplifying that I can do on the left side or the right side of this equation. So I'm going to skip step 1, and I'm going to move on to step 2. Determine the inverse operations needed to get the variable all by itself. So I'm going to be doing this in reverse PEMDAS order. My goal is to get y by itself, so I want to get rid of everything that's attached to it. Reverse PEMDAS order says I look at addition, subtraction first. So this 4x is being added to the y. So I'm going to get rid of it by subtracting 4x from each side of the equation. Remember, each side of the equal sign. So I'm left with 3y on the left, and that equals 9 minus 4x on the right. Now I want to divide the 3 away. Now, here's where a lot of students make mistakes. They can do division by 3 on the left side of the equation. They know that 3 and the 3 cancel out and you're left with y. But they make a mistake on the right-hand side. Dividing by 3 is the same thing as multiplying by a third. If I divide the right side of the equation, I have to do the distributive property with my division. I have to divide all parts of that math problem by 3. As far as I'm concerned, you can leave the expression like that. You can leave it as 9 minus 4x over 3. But if you do choose to do 9 divided by 3 is 3, then you better also divide the negative 4x by 3. Either one of these answers is acceptable. I would say that students typically feel more comfortable with the top version because students often make mistakes when they try to do the bottom version. But so often I have students just do the 9 divided by 3 because that's 3, that's easy, and then they leave subtracting 4x, and that's incorrect. You can't mix and match these solutions. You either have to write it as a full division problem or as a fully distributed division problem. Let's do another example. This time we want to solve the literal equation for x. We want to get x all by itself on one side of the equation. Now, if you ever come up with a situation where x is in two places in the equation, the best thing to do is try to factor out, I have it written over here, you want to try to factor the variable out. You want to try to do the reverse distributive property. So in this example, we've got y equals, now I want to try to have x outside parentheses and see what's left inside parentheses. If I divide the x away from the first term, I'm left with 3. And if I divide the x away from the second term, I've got 5z. Now, if you're not sure you've done it correctly, you can do the forward distributive property. If I do x times 3, that's 3x, and if I do x times 5z, that is 5xz. So it does work out, and I've done it correctly. Moving on to the next step, now my goal, remember, is to get x all by itself. So I want to divide away anything that's multiplying the x. Well, this whole expression, 3 plus 5z, is multiplying the x. So I'm going to divide away that whole expression, 3 plus 5z. But whatever I do to one side of the equation, I have to do to the other side, 3 plus 5z. And what I'm left with, because even though it's a huge division problem, it cancels out. X equals y over 3 plus 5z. And that's my answer. I have rearranged the literal equation so that x is all by itself on one side. So, formula for surface area. If I have a rectangular prism, the surface area of the rectangular prism is 2 length times width plus 2 length times height plus 2 width times height. And it says solve for length. So I want to get length all by itself on one side of the equation. Well, first thing then, these two terms contain length, but this one does not. So I'd like to get rid of this 2WH and bring it over to this left side of the equation. So I'm going to subtract 2WH from both sides. And that gives me S minus 2WH equals 2LW plus 2LH. Now my goal is to get L by itself. So I'm going to use the same strategy I did in the previous question where I pulled the X out. I did reverse distributive property. I want to do the same thing on the right side of the equation. I want to take the L out. And when I take the L out, I'm left with 2W in the first term and 2H in the second term. On the left side of the equation, I still just have S minus 2WH. And now to get L by itself, I want to divide away the big thing in parentheses, this 2W plus 2H. Divide away the 2W plus 2H. And on the right side, that cancels out the big math problem in parentheses. So I'm just left with L on the right-hand side. And on the right-hand side and on the left-hand side, I've got S minus 2WH over 2W plus 2H. So it's a big, clunky formula, but we have rearranged this formula to solve for L. Let's look at how we might use this skill when solving a real life problem. So if you own a rectangular plot that is 500 feet deep and an area, remember area is length times width, an area of 100,000 square feet, to pay for a new water system, you are assessed $5.50 per foot of lot frontage. So that's the width. The width is the same as the frontage. How much are you assessed for the new water system? So basically, I want to know what's the width, and then I can take the width and multiply it by $5.50. To find the width, I have to think about area equals length times width. I want to know what the width is. So I'm going to solve this literal equation for W. I'm going to divide by L, to get W all by itself on one side of the equation. I get area divided by length gives me the width. So I'm going to plug in my area, which is 100,000. I'm going to plug in my length, which is 500, and that leaves me with my width. And the answer that I get is 200. And if I plug that 200 in, remember the cost is going to be $5.50 times that width. So if I do $5.50 times 200, I'm going to get charged $1,100 is the final answer. Now, if you ever get given a real world problem like this on a test, it's important to realize that while it's nice to be able to rearrange the literal equation as is, and you will often earn points for that, it doesn't mean you should skip the whole question if you're struggling with rearranging literal equations. Because what you can do is you can write down area is length times width, and then you can plug in the numbers you know into the original equation. The area is 100,000, the length is 500, and the width is what we're trying to figure out. So if we divide by 500, the width is 100,000 divided by 500. And we can do that calculation and still get the 200 answer. So if you ever get given a real world example, it could help you to plug the numbers into the original equation, then say, hey, how did I do that? Oh, I did the area divided by the length, and kind of work backwards to get that literal equation. Let's do some more real world problems. The equation to convert temperature from Fahrenheit to Celsius is shown here. Solve the formula for F. So here my goal is to get F all by itself. So I basically want to know, hey, how do I calculate Fahrenheit if I'm given Celsius? The equation shown is how do you calculate Celsius if you know Fahrenheit? How do we get F all by itself? Well, remember, reverse PEMDAS order. So you do addition, subtraction first, but parentheses comes last. So even though this looks like subtraction, it's inside parentheses, so we're going to do it last. Let's focus on multiplication division first. If I've got a 5/9 here that I'm multiplying my F expression by, then what I want to do is I want to multiply by 9/5. Multiply both sides by 9/5. So I have 9/5 C equals Fahrenheit minus 32. Now I'm going to deal with what's inside parentheses. I'm going to add 32 to both sides of the equation. And that gives me Fahrenheit is 9/5 C plus 32. And that's rearranging the formula for F. Now I'm being asked the surface temperature of Mercury is 427 degrees Celsius. Use your answer from part E to calculate the temperature in degrees Fahrenheit. So I've got 9/5 times my temperature in Celsius, which is 427 plus 32 equals F. And if I plug 9/5 times 427 in my calculator, that's 768.6 plus 32, and that's going to equal 800.6 degrees Fahrenheit. Again, if this was a series of test questions, you could still plug in this value for Celsius here and then use reverse PEMDAS order to solve the equation. In part G, question G, the textbook asks you to do a simple interest calculation. This is the formula for simple interest. I won't expect you to have it memorized. I'll give it to you, or it might be on your data sheet on a test. But interest is the principal times the annual interest rate in decimal form and the time in years. So here, the time has to be in years. So 6 months is going to be 0.5 years. My principal is 5,000. My time is the 0.5 years. And I know my interest is $162.50. And I want to know what's my Great. So the R is the thing that I'm missing. So if I've got I equals PRT, I want to solve this for R. I want to get R all by itself on one side of the equation. That means it's being multiplied by right now by the P. It's being multiplied right now by the T. So I want to divide away the P and the T. Divide away the P and the T to get R all by itself. R equals I divided by P times T. And P times T is together in the denominator. So if we plug in the values that we've been given, the interest is 162.50. The principal is 5,000. And the time is 0.5. And so if you do the multiplication, you get as your answer that the R is 0.065. And if you wanted to write that as a percent interest rate, remember this decimal is out of 100. So if you want to convert that to a percent, you multiply by 100, which is 6.5% interest rate. That 100 is there to help you convert to a percent. Okay. If you answered with this decimal on a test, that would be acceptable as well. What's not acceptable is to say 0.065%, because that is not a percent. You need to write it as a decimal or as a percent. Don't combine the two. Lastly, let's look at the different versions of the speed equation. We've used these a few times across this chapter, but now let's work on actually rearranging this literal equation. We know that speed is distance divided by time because like miles per hour, miles is a measure of distance, hour is a measure of time. So S equals D divided by T. How do we solve for T? What do we do to get solving for D first. What do we do to get D all by itself on one side of the equation? Well, I want to get rid of the T that's dividing it. So if I write down S equals D divided by T, it's being divided by T. So I want to multiply both sides of the equation times T. T divided by T is 1. That causes the T to disappear because the two T's cancel out. And I get T times S equals D. How do I solve for T? Well, if I have S equals D divided by T, I want to get T all by itself in one side of the equation. But remember, it doesn't count as the variable being by itself if it's in the denominator. So my very first step here is to get T up out of the denominator. One way to do that is what I did in the previous section. I multiplied both sides of the equation by T, and that gave me TS equals D. Now T is up top. It's not in the denominator anymore. So now I can focus on getting rid of anything that's multiplying it. I'm going to divide the S away. Divide the S away. And that leaves me with the equation T equals D divided by S. Another way to look at this would be to do cross multiplication. So if you imagine S as being S over 1, you multiply the denominator on the left times the numerator on the right, the denominator on the right times the numerator on the left, and you get S times T equals 1D. Notice that's basically the same thing we had written here. And then the next step was to divide both sides by S, and you still get T equals D divided by S. Let's apply the equations we've just derived. A driver averages 60 miles per hour on her outbound journey and 50 miles per hour on her return trip. Her total driving time is 6 hours and 36 minutes. How long does each trip take? One thing I want to do is I want to combine this into one figure. I'd really like to write this time as a decimal, not 6 hours and 36 minutes. 36 minutes. Remember, there are 60 minutes in an hour. So 36 divided by 60 is 0.6 hours. So her total driving time is 6.6 hours. So that's what I'm going to want to use here. Her total driving time is 6.6 hours. So if I know that time is distance divided by speed, then I can say that her time for trip 1 and her time for trip 2, if I add them together, is going to be 6.6 hours. And then I can rewrite time 1 as distance divided by speed, and I can rewrite time 2 as distance divided by speed. So we've got distance divided by speed 1, and we've got distance divided by speed 2 equals 6.6 hours. Okay, the distance is the same. Distance 1 equals distance 2. It's just her speed that changed. So the distance doesn't need to have a distance 1 and a distance 2. It's just distance. But my speed 1 was 60, and speed 2, I guess it was rush hour or something, she couldn't drive as fast, is 50. That equals 6.6. Now, here I have two fractions that I'd like to add together because I really want to have just one term with a d in it. However, when you add fractions, they need to have a common denominator in order to be able to add them together. So rather than adding these together, I'm going to use a strategy we used in a previous lesson where I'm going to get rid of the fractions altogether by multiplying both sides of the equation by 300. 300 because it's the least common multiple of 50 and 60. Multiplying both sides of the equation by 300. Using the distributive property, 300 times d divided by 60 is 5d, and 300 times d divided by 50 is 6d, and 6.6 times 300 is 1,980. This is a much more straightforward problem to solve than having those big fractions. So 5d plus 60 is 11d, which is 1,980. Divide both sides by 11, and you get d equals 180 miles. 180 miles isn't actually the answer to the question. The question is, how long does each trip take? Now that I know the distance, I can find out that the outbound journey was distance divided by speed, which is 180 divided by 60, which is 3 hours. And my return journey is distance divided by speed, which is 180 divided by 50, which is 3.6 hours. So it is helpful to be able to take a formula or other literal equation and be able to rewrite it to solve for a particular variable for use in problem solving. I hope this helped.